Hello, welcome to this section. We're going to be talking about interacting with mathematical functions and some important multivariate functions. These functions are actually pretty useful in machine learning. Getting a good understanding of these core ideas is extremely helpful. So I have some code here, and I basically wrote out some type of a couple of functions that are pretty you should pretty much know. So I mean, like I'm going to start with the linear function here, and you could see kind of just playing with the slope that the steepness increases. Simple enough. The next one is a polynomial function. Now you see that these two first terms are negative, right? So like, what if I was to go positive? What would happen to it? Um, well, for the x squared, it would invert, okay? So the idea is if for this term, basically, if it goes negative, it would invert. Okay. And then we're playing with the constant here. I mean, you could just kind of see that the shape and the magnitude of the values changes, right, when we play with these things. So that was kind of the idea behind the polynomial function, something that's useful to understand in depth. I know that like when people just see a graph, it's really not too intuitive, but when you get to play with parameters, um, your understanding will definitely increase about the function. Here we've got an exponential function, right? So we've got scale. If I go up here, it increases, right? We see that it went from 2000 to about, I don't know what this value is, about 100,000, right? So that's that's in front of the exponential, which is the coefficient. Now, what if we played with the exponent value, right? It inverts if it goes negative. Once it goes positive, it changes sides. And you could see that if I go farther out, I mean, I was the increase becomes a lot steeper at a certain point. Okay, so that's the basics of an exponential function. Here we've got a Gaussian, which is basically this term squared, right? You could see that it's x squared. And you'll see that, I mean, it's a normal distribution and it's useful to model all sorts of things. I mean, it's a fundamental idea in statistics, and it's a fundamental idea in machine learning as well. I mean, as a result. So I mean, if I play with this, you could see kind of what happens. Like the main thing to look at is kind of the tails right here, where more unlikely events, the values that are pushed outside are more likely to occur, right? So there's more density here or probability mass. So that's the Gaussian function. Um, Now I kind of talk about briefly, basically, multivariate functions, right? This is like x squared plus y squared. We have to add the y squared, right? I mean, here it was univariate, where it's just x. Here we have x and y. So like I show like a function with a minimum, function with a maximum. Now this is important later on for optimization. These ideas, kind of like finding a global minimum and a global maximum. Most likely in, say, something like gradient descent, you would want to find a global minimum. Gradient descent is a optimization algorithm that's commonly used in machine learning, and we'll be touching on that shortly. And here's a saddle point, and this has no maximum and no minimum, and that's basically the idea. It's a little bit of a strange function, but so that about wraps it up. Thank you very much, and I will see you shortly.